Hi, in this video we're going to learn about transforming quadratics or parabolas. So the form of the quadratic that we are going to be looking at is called vertex form. And you'll see that there are three numbers that we're going to be changing, a, h, and k. So the x and the y are going to stay the same, but the a, h, and the k are what we're going to be changing, and these are going to be the parts that are going to be transforming our quadratic. So the reason why this is called vertex form is because h comma k is our vertex. So if you're looking for the vertex of the quadratic and it's in vertex form, you're able to see it right away. So let's talk about what each parts of this equation does. So A kind of has two rules. When A is positive, that means that our graph is going to open up. When A is negative, that means our graph is going to open down. So you've probably seen a parabola that opens up like this. So it looks like a U, and then opening down, it looks more kind of like an N. So a positive A value means that the graph is going to open up, and a negative A value means that the graph is going to open down. Now, A also is our stretch and our compression factor. So it's going to make our graph look really, really skinny, and it's also going to make our graph look really, really wide. So we always talk about the absolute value. So if the absolute value of A is greater than 1, that means that our graph is going to be stretched. And when I mean stretched, it's going to look very skinny. And then when A is equal to 1, our graph is normal. There's no stretch or compression. And then when A is between 0, 1, and again, we're looking at the absolute value of this. What this is going to be is compressed. So we're just looking at the A value itself. We're not actually looking at if it's positive or negative, because that's the part that tells us if it's opening up or opening down. We're looking at the absolute value of it. So it doesn't matter what the sign is. We want to see what is just the A number itself. If it's more than 1, it's going to be stretched or skinny. If A is equal to 1, it's normal. And then if A is between 0 and 1, it's compressed, which is going to be wide. So our graph is going to look very wide. Okay, now let's talk about H. So if we have a positive H value, that means our graph is shifting to the left. And if we have a negative H value, that means our graph is shifting to the right. So we can kind of think of it as like opposite of what we think. Positive, we usually think going to the right, and negative, we think going to the left, so it's actually kind of flipped of what we think. And then lastly, we have our K value. And our K value, if it's positive, that means that we're shifting up. And a negative K value means that we're going to shift down. And this is just the movement kind of the vertex of the parabola. Where is the vertex moving? So remember that the original equation without any transformation starts at 0, 0. And then the H and the K are going to kind of dictate where it kind of moves around the graph. So let's take a look at some of the problems that you might see regarding transformations of quadratics. So the first type of problem is you are going to be presented with an equation and you're going to have to identify the transformations. Now what I always do is there's 4 different transformations. Is the graph opening up or down? Is it stretched, compressed, or neither? Is it shifting left or right? Is it shifting up or down? So there's 4 different types of transformations. So because there's a positive, an invisible positive, that means that our graph is going to open up. This 1/2, since that's between 0 and 1, that means that our graph is going to be compressed. So it's going to look pretty wide. And we can even say compressed by 1/2. And then this +2, remember we want to think opposite, so this is actually going to the left 2. And then this +3 at the end, it's going up 3, because remember that k value at the end is just normal, so it's shifting up 3. So you always want to kind of list the 4 different types of transformations so that you make sure that you hit them all. Another type of problem that you're going to see is write the equation of a quadratic that opens down, shifted right 8, shifted down 6, and is stretched by a factor of 2. So if you remember, our general equation is y equals a x minus h squared plus k. So what we want to do is we want to plug in our values for a, h, and k based on what we see in this problem here. So the first thing I see is that my graph is going to open down, so I know that I need to have a negative in the front of my equation. So then I can kind of leave the rest of the equation. I know x is going to stay the same, the parentheses, and the squared. I also know that it's been shifted right 8. So remember, our shift left and right is h. Shifting to the right is negative, so x minus 8 squared. And then it's shifted down 6, so minus 6 at the end. And then the last part says that it's stretched by a factor of 2. So remember that a is our stretch and our compression factor, so that's where I'm going to put the 2 in the front. So this negative tells me that it's opening down, the 2 is the stretch, minus 8 is right 8, and then minus 6 is down 6. And then we can even go a step further and say that the vertex of this quadratic is going to be at positive 8, comma negative 6. So remember that we're kind of flipping the sign when we pull that 8 out. The last set of problems that you're going to see are identifying the equations of graphs. So the first thing that you always want to do when you're trying to identify the equation of a graph is identify the vertex, because that'll already give you h and k. So our vertex is right here. It is at 1, comma negative 3. So remember, this is going to be your h value, and that's going to be your k value. So we have y equals, we don't know anything about our a value yet, but I know this is going to be x minus 1 squared minus 3. Remember, inside the parentheses, we have to flip that sign. So it was positive 1, now it's becoming negative 1 in that equation. The next thing that we want to do is work with our a value. Now I know my graph is opening up, so I know my a value is going to be positive, but I need to know what the actual a value is. So what you're going to do is you're going to see, what do the 2 points on the side of the vertex look like? How far away are they? So we want to go over 1, up 1. So that means that they're 1 away. So that means that our a value is just simply 1. It is normal. If it was 2 away, we had to go over 1 and up 2, that would mean that our A value is 2, or over 1, up 3. So you always want to go 1 away from the vertex and see how far up you have to go and match your A value. And again, that 1 is going to be positive because our graph is opening up. Same thing with this next one. Our vertex is located right here. So that's at -2, +4. So I have my equation y equals x squared. So I can go ahead and put my vertex in, and remember that -2 is not going to become +2. And then -4 at the end, or +4, sorry, +4 at the end, because the k value stays the same. Only the h value needs to switch. Now looking at my graph, I know that it is opening down, so I need a negative. And then if I look at the points that are next to my vertex, I go over 1 and down 1, over 1 and down 1, so that means that again my A value is still 1. So you're just seeing how far down do you have to go after going over 1. Make sure that you pay attention to the fact that it is opening down and that we do need to have that negative in front. Thank you so much for watching.